This is a video on solving inequalities or inequations. These questions involve something that you might not have had to deal with before. When you were doing equations, you had things like 2x equals 10, and you could divide by 2 and divide both sides by 2, x equals 5, and that was not a problem. If it was minus 2x is equal to 10, you could divide both sides by minus 2 and still no problem. Some unusual things happen with a greater than, less than symbol when we divide and multiply by negative numbers. I want to show you something that demonstrates that nice and easily. If we take something nice and sensible like 2 is greater than 1. This is just a correct statement. 2 is greater than 1. If I multiply everything in this line by negative 1, what happens? I then write down, well, negative 1 times by 2 is negative 2. I write down 1 times negative 1 is negative 1. And when I go to write my sign back in to make the whole thing match up, negative 2 is not greater than negative 1. This is just wrong. What has just happened is that we forgot that this symbol is also being multiplied by a negative number. Now, in reality, we've always been doing that. It doesn't have a value, so being multiplied by the 1 doesn't matter. It may as well have been a 2 or a 17 or a whatever. That doesn't change that symbol's value. It's simply a greater than or a less than symbol. But the negative sign changes its direction. It has to turn and face the other way. And when it does, this question now makes sense. Negative 1 is greater than negative 2, or if I read from left to right, negative 2 is less than negative 1. Now that's important to us because when we start to try and solve questions like this, if I have, let's say, 5x plus 3 is less than 17, what do I get? I take 3 away from both sides, all good so far, and I end up with 5x is equal to 14. I divide both sides by 5. I've divided by a positive number, and positive numbers don't change the sign of things when we divide or multiply. If they don't change the sign of numbers, they're not going to change the direction of our symbol just there. Now 5 goes into 14 2 times and 4 left over out of 5, so x is less than 2 4/5. But what if my question was a little bit different to that? What if my question was 10 minus 2x is greater than or equal to 6? Well, now I have to take away 10 from both sides to get that 2x by itself. Notice that this is still working just like equations. Nothing else is changing here except for what happens in just a moment's time when we divide by minus 2. Let's just finish off this first bit. 10 minus 10 is gone. 6 minus 10 is negative 4, but now I've got to divide everything by negative 2. Well, remember, if I'm dividing by negative, that changes the direction of that sign. Negative 2 divided by negative 2 is 1. Negative 4 divided by negative 2 is positive 2. And so the one change from equations that we get here is if we multiply or divide by a negative number, the sign that sits in the middle would have to change, as it did in this question. That doesn't happen to equal signs because they don't have a direction. But this symbol does have a direction, and we have to change its direction if we are actually going to multiply and divide with a negative.